Hello, this is a pre-recorded presentation of the flood-related multimedia task organized by the Information Technologies Institute of the Center for Research and Technology Hellas in Greece and the Alto Adriatico Water Authority in Italy. The task focuses on floods since they are the most frequent natural disaster and affect most places on Earth, causing a vast number of deaths and damages. Citizen crowdsourcing and social media posts have been proven valuable in all stages of managing such a disaster. They can notify about a possible disaster in the pre-emergency phase, they can provide insights on the evolution of the incident and detect areas in danger during the disaster, and they can assist in the damage control in the post-emergency phase. However, the large and continuous streams of published posts carry a lot of noise, for example, the metaphorical use of flood-related words, incidents outside the area of interest, or past events, which makes it difficult to collect high-quality information. Automatic estimation of a tweet's relevance could address this challenge by filtering out unrelated posts. Better ability to separate relevant and not relevant tweets will contribute to improving the quality of the incoming information to support first responders and civil protection authorities. The flood-related multimedia task tackles the analysis of social multimedia from Twitter for flooding events. In this task, the participants receive a set of Twitter posts, namely tweets, and their associated images, whose text contains keywords related to floods in a specific area of interest, specifically the Eastern Alps partition in northeastern Italy. However, the relevance of the tweets to actual flooding incidents in that area is ambiguous. The objective of the task is to build an information retrieval system or a classifier that is able to distinguish whether or not a tweet is relevant to a flooding event in the examined area. The dataset of the task consists of Italian language tweets, motivated by the common flood events in the cities of Eastern Alps, such as Venice, Vicenza, Trieste, and surrounding areas. We also chose Italian for this task in order to encourage researchers to move away from a focus on English. Participants can tackle the task using text features, image features, or a combination of both. The dataset is a list of social media posts that have been collected from Twitter between 2017 and 2019 by searching for Italian flood-related keywords inside the tweet text. The development set comprises 5,419 manually annotated tweets, while the test set 2,079. All tweets contain an attached image and were still online at the time of releasing the dataset. In order to be compliant with the Twitter developer policy, only the IDs of the tweets were distributed, but a tool to download them was also provided. The ground truth of the dataset was collected with human annotation by the Alto Adriatico Water Authority, who are experts on flood risk management in the Eastern Alps partition of northeastern Italy. The participants were allowed to submit up to 5 runs. In the required run, they were asked to propose a fusion of textual and visual information. In the second run, they were allowed to use only textual information, and in the third run to use only visual information. The 2 general runs permitted every automated solution, including using data from external sources. The correctness of retrieved tweets for the 2 classes, relevant and not relevant, were evaluated with the F1 score metric on the test set. Regarding the participation to the task, 10 teams were initially interested and registered, while 5 teams proceeded with submitting their results and their working notes papers. In more detail, there were 4 submissions in the run of used textual and visual information, 5 submissions in the run of textual only, 4 submissions in the run of visual only, and other 5 submissions in the general runs. Let's take a look at the results. In the first run, the FAST and UDS team came first, followed by QUT. In the second run, where all teams participated, FIG had the best performance and also achieved the highest score among all runs. It was followed by UEHB, ML, and QUT. In the visual-only run, Fast and UDS managed the best score, followed again by QUT. Finally, in both general runs, UEHBML ranked first. By comparing the results per run, we can easily see that using only the textual information achieved much higher scores than the other runs, while using visual and fused information performed quite similarly. Now some remarks based on the working notes and the results of the participating teams. We can see a variety of methodologies used. For the text representation, the participants preferred bag of words, term frequency, inverse document frequency, and BERT. For classification, they used multi-layer perceptron, recurrent neural networks, convolutional neural networks, support vector machines, random forest, and multinomial naive Bayes. To tackle the class imbalance, the teams used mode and documentor for oversampling and random undersampling. In general, it proved to be a very hard task, since the average F-score was 0.22 and the maximum achieved score was 0.54. The fact that most teams had significantly better results in the validation set rather than the test set can be partially explained by overfitting and partially by the subjectivity of the annotator. As seen in the previous line chart, using the textual features had a much better performance than the other runs, while the best score was achieved with undersampling and a combination of 3 artificial neural networks. Before concluding, I would like to present the organizers of the task. From the Information Technologies Institute of the Center for Research and Technology Hellas in Greece, the task was supported by Stelios Andreadis, Ilias Gialampoukidis, Anastasios Karakostas, Stefanos Vrochidis, and Ioannis Kompatsiaris. From the Alto Adriatico Water Authority in Italy, the task was supported by Roberto Fiorin, Daniele Norbiato, and Michele Ferri. I would also like to add that the task was supported by 3 European projects under Horizon 2020 program: Be Aware, eOpen, and Aqua 3S. Thank you very much for watching this video.